Not on. Hey, Sean.
Hey, Bill. How's it going?
Good. How are you, sir?
Pretty good.
What a disaster. The closings.
Oh, it started without me.
Oh my God. Well, basically what happened was when first I couldn't find her because I had the whole waiting list. Everybody was already in the queue and she hadn't shown up yet. But then I somehow, when I let her in and then I transferred over the controls. Once I do that, we didn't talk to her about having to let everybody in. So I think there had to be 30 or 40 in the waiting room. Didn't get it. So I wrote everything down. We got some improvements. We do a Kaizen event.
Bill, if you want to send over that recordings, Steven, I don't know if tomorrow if you have time to trim
Send it out tomorrow if we can. I was going to mention that. Why don't we send the recording out right away? Because I had Karen had emailed me after, and she was trying to get in and stuff, and she said, "Well, you have the recording." I said, "Yeah, we'll try to get it together quick and get it out this week. That way." But I mean, that's good. A lot of people, actually, the one that we sent out today, 6 or 7 people downloaded it just before the other 8 closing ones from 2 weeks ago. So that's good.
Yeah, I had.
Bill, you're not going to sleep tonight, are you?
No. No.
Bill, think of it this way: if a dozen people reached out saying we can't get in, that means people want to attend these.
Yeah, it is.
You create a culture where people want to attend them.
I just felt bad for Christian, in that position. It was just awkward.
I thought she did pretty well. So.
Yeah, she did.
Yeah.
Hey, Daniel, I thought you were going to miss us today.
My professor ended up canceling the class, so.
You got a better class today then. That's good.
Thanks.
Yeah, down the stretch we go today. I mean, we got I'm gonna teach you the other 10 different types of control charts. We're gonna get into a control plan a little bit, what that looks like. I'm gonna show you my wife's frozen yogurt sales. And we're gonna do a quick accumulative sum on that little exercise with her weekly sales since 2014, and then we do a little bit of lean controls, and then next week we'll do the review, and I'll probably, after the review, I'll send you the final exam. And I was thinking about I would love for you to try to do it with closed book, and if you don't mind doing that, do a closed book and send it to me. And then if you want to do a closed book, go ahead and do it and send it to me. I'll take the higher of the 2 grades. But what I'm interested in is, did I cover it? Like in terms of, did I communicate what I thought was important? Well, and if you do an open book, I won't know that, if you guys don't mind. And I guarantee you, after the review session, I think, it'll be easy to do closed book.
We don't have a choice, Bill. You were going to tell us when we should start taking notes, and you never said to. So.
What's that?
You were going to tell us when we should start taking notes, and you never told us to start. So.
I know, right? And then the other piece is, I saw Stephen already started his presentation. So next week the review does not take a long time. So maybe, if you're ready, Stephen, and if anybody else is, we can start that process, because then that following week, all we're going to do is, the rest of the presentations. That's it. So.
Bill, can you hear me? Yes.
Yes.
You had indicated you wanted to send a presentation that someone else did, Rose, I believe it's her name.
Yeah, did you guys get that?
But I don't think you ever did. So I really don't know what I should try to emulate or copy, unless.
Yeah, I don't think I got it either. Yeah.
It was mentioned in the body of the email, but I don't think it was part of the email.
And that kind of.
I got it.
You got it?
Yeah. It was in one of the emails for me, at least.
As an attachment or
It
link?
was in with one of
Yeah, like a YouTube video.
I watched the YouTube video, but it was our class. Sorry.
Okay, so I'll make sure that I get that to you, okay? Because it's just basically like her take on the project. Stevens is already completely different, which is what I'm hoping for. But I'll get that to you.
She she implemented basically like everything. Did you want something like that, or you wanted us to like pick our favorites?
Yeah, pick your favorites. Have fun with it.
Okay, so like maybe like our top 3 or top 5 or something.
Yeah, I mean, whatever. Like you basically come up with, some kind of an approach. Maybe it's a hypothesis on how things are correlated, or there's a whole bunch of years there. So it's, how have I deteriorated over time? I mean, there's a whole bunch of ways you could approach it. So there's no wrong answer here. It's just like I'm hoping that you use a few tools and have some fun with it.
Is there a central question you want us to get to the bottom to, or is it just here's your health, make some sense of it?
Yeah, you're a doctor, and you have a whole bunch of data laying there sleeping.
That's right. Okay.
All right, so let me jump into today's class. We're gonna get into a control chart for non-continuous data. So it's yes/no stuff, specifically defects and defectives. The difference between those two things. This class, and when we get into that, you can file it under good to know. Thanks. All right. There's nothing on the exam about it. I'm going to it's similar to the end of the hypothesis tests. When we were getting into the ones that we're not going to use very often. Well, that's kind of where we are with these. So it's for your information. You can't say that I didn't expose you to it, but don't lose sleep over the formulas and all that. All right. I'm hoping that at least I can communicate the why to you in terms of, why you'd use a certain control chart. So without further ado, we switch. All right. This got going a lot better than the closings. All right. So let me just back up a sec. Just a quick review. Last week, we got to types of variation, data collection, control chart structures and rules. And then we got into 1MR, which is the homework, XBAR-R, XBAR-S. And today we're going to get into everything on the right side here. These are different types of control charts that we use with, like I said, non-continuous data. And then we get into a control plan, which is a lot of words, how you present the control plan and how you lay it out, to the business. And then we'll finish up really quickly with some 5S controls. I'm not going to spend a ton of time on this again, because you guys are all lean people. You do it for a living. I wanted to go to this particular flow diagram. I don't want to go by it. I'm having a rough day, huh? Not on. I went by it. There it is. Oh my God. Please hold. This seems like my day today, guys. There it is. All right. So let me start here. So if you remember, the idea of the control chart is we want to know, once we make some improvements, and we're starting to measure our new improved process that we think is capable and predictable. And a nice tool, SPC is a tool to make sure that we kind of keep everything in the lines. Remember, we went through the Western Electric rules of when do you raise your hand and say, hey, let's take a look at that. Something looks funny, right? So those rules pertain to all of the control charts that we're talking about, whether they're the ones we talked about last week or the ones this week. So what we covered last week were obviously to the right, the continuous data, and subgroup sample size is the first, when I say a subgroup, so if I'm going to sample, let's say I'm going to sample 3 times a day, And each sample is 5 parts. My subgroup is those 5, right? Those 5 parts. So depending on the sample size, I might use an IMR, an XBAR-R, an XBAR-S, and they all use, what I'm plotting is individual and moving range, or means in ranges, or mass and standard deviation. And we got into, the 2 charts together to look more closely. Today, we're going to get into looking even closer with non-continuous data. So that's the left side here. And what we're looking at here is, are we talking about defects or defectives? And the difference is, when we talk about defectives, we're talking about the whole thing, right? The whole thing is defective. When we talk about defects, well, a defective part might have 3 or 4 defects on it, all right? If we're talking about defectives, then we're going to talk about an NP chart and a P chart. And we're going to spend most of our time there, even though I'm going to go real fast on those. And if we're talking about defects, we're going to talk about a C chart and a U chart. All right. Skip ahead. Again, I went right by it. There we go, ND. All right, so now picking up the same theme, with these control charts, we're talking about it upper and a lower, we want to keep our data. We're usually talking about a center line of some kind. Now, this data is, again, it's things that we count. It could be pass fail. It's not something we measure, right? That's what when we use these charts. So the NP chart plots the number of defectives in one subgroup as a data point. So if my subgroup is 15 samples and I have 5 defective parts, then that's what I would plot, right? In order to use the NP chart, my sample size has to be the same all the way through, all along. And there's other types of control charts where you don't have to worry about that. And then the underlying distribution is obviously binomial. So again, if you remember last time, we were talking mostly about the mean and the homework, even in terms of the center line and our distance of, whether we're staying within the upper and lower limits. Again, we have a data point, X1, which is the number of defectives in the subgroup. The center line, there's the calculation for the center line. So again, you do is, in order to get that center line, we're not using mean. We're using the sum of all my defectives divided by the number of subgroups, and that's how we get our center line. And then the control limits, we're using the theme of the center line is always, the upper and lower limits are always going to be 3 standard deviations, right, away from the mean or whatever we're measuring. So the formula there is, for the control limits, you have to do it for both. One is plus 3 standard deviations, one's minus 3 standard deviations away from the center line. But again, the same rules apply. 4 data points fall beyond. The same Western Electric rules apply to all of these charts. Right. The P chart is a control chart monitoring the percentages of defectives. So instead of number of defectives, is what's the percentage of defectives in a subgroup. Okay. Sample size does not need to be constant. So what that means is, if the sample size doesn't need to be constant, then my upper and lower, they're not going to be straight lines. As you'll see, they're going to be depending on how many samples I have, as you see. And again, the underlying distribution is binomial. Here's the formulas again, same theme, right? What's my data point that I'm measuring? How do I figure out my center line? And how do I figure out my control limits? And you can see the upper and lower control limits are not straight lines, because it's going to depend on, based on these formulas, what my subgroup size is. So it's going to change that way. I told you I'm going to go fast. A C chart is a control chart that monitors the number of defects in a sample now, right? Because I might have more than one defect in a defective part, right? So the C chart plots the count of defects per unit of a subgroup as a data point. You have to always have the same number of samples to use it. And the underlying distribution is +1. So the C chart equations, there's the data point, the center line, and the control limits. All you got to remember on diagnosis is same Western, Western electric rules for when do I pay attention, those 8 rules. A U chart monitors the average defects per unit. Now the average defects, not the number of them, okay? It plots the average number of a subgroup as a data point. The sample size is not constant. And again, the underlying distribution is Poisson. There's the formula for the data point. Guys, if you want to try to do these like in Excel, this is probably where, you'd use Manytab, like a lot of these, in order to automate these equations. Not really easily done in Excel. I was going to do one of them. I was like, that's going to waste, that's going to take 20, 25 minutes of our class. So I punted. But again, the same theme. There's the formula for the data point, center line, and control limits. And same thing, except this time here, don't forget, we can, the sample size can change if I use this tool. I mean, the idea here is that, with these tools, especially when we get into cumulative sum, you can see very, very fine changes in the process. Critical things like medical applications, where, a tenth of 100% of an ingredient makes a huge difference, and you want to catch that really quickly. And the cum sum, I'm gonna show you this one. It's a pretty simple concept. You probably used it in the past, especially in sales. Basically, it's a control chart of monitoring the cumulative sum of the sample mean deviations from the process target, right? And that's a lot of words for what you'll see when I show you. It detects the shift of the process mean from the process target over time. It's a normal distribution underlying, and there's 2 types, one two-sided and 2 one-sided. The two-sided, there's a tool called a VMask that has its own calculation, and basically instead of using control limits, it's a mask that you kind of put over, you'll see in a second, you put it over your data, and anything that falls outside the V is considered to be out of control. I mean, that's what it looks like. If any data points in the cum sum chart to the left of the origin point or outside the VMask, the process is considered. So I'm going to use, this is the last data point where the red dot is, and there's a formula basically rise over run in order to draw this VMask. And anything that falls out, I think I have one. No, I don't. It might be a piece of data, a data point that falls outside of that, tells me my process isn't in control.
In what situation would you use this with those one descending line and one rising line rather than control chart?
When you don't want you don't want a variation of more than 1 sigma. Like very fine, very fine process changes that make a huge difference. And again, the calculation itself, in order to, each of these points, they have their own formula, and it's, that would be when you'd use it. 99.9% of the time, we're going to use the one you did for homework, most of the time, right? The other thing is I can use some of these other ones when I have more than one thing at the same time that I want to keep an eye on. All right. You guys get this. Let me switch over real quick. I'm going to just do a real quick Q sum. It's a cumulative sum is what it means, right? So this is my wife's, this is real data. Don't tell her I gave it to you. But it's basically her weekly sales from the yogurt shop from February 25th, 2014, all the way to, I think, Valentine's week, this year. So
We don't see that, Dale.
Yeah.
We don't see that. We still have the,
Oh,
are you showing us something different?
I'm having a rough, no, I forgot to share it. I think I'm gonna go to bed. I'm having a rough day.
Isn't
Everything I touch turns to crap today. I don't get it. How about now? Sorry about that. Done a lot of today's.
Is it a frozen yogurt shop?
Yeah, it's my wife's frozen yogurt shop in Windsor. All right, so first we'll draw a quick line graph, right? So I'm just gonna highlight the data. I'll just highlight this data. Insert line graph. I'll use that one. Why not, right? And from this graph, what can you say? I can put the dates down the bottom, but you get a general idea of what sales look like over the last 6 years or so. What can you tell me?
It's seasonal.
Hey, right? You got the roop, right?
Yeah.
Crazy, right? And then what might you be able to tell me about the last 10th of this graph?
COVID.
Yep, that's COVID. All right, and I'm gonna erase this now. So that's the bloody picture, and thank God for the PPP. I'm gonna add another column. I'm gonna call it cumulative sum.
It also tells me you got to move to Florida and open that froyo shop.
Oh, neither of those are closing.
Really?
Yeah, my wife, what saved my wife? We talked about Kanban a couple weeks ago. Kanban saved her, because largely she doesn't buy anything that we haven't sold. So what they do is they take the yogurt out of the freezer, the employees mark it on a chart, whatever's on the chart at the end of the week, that's what she buys, no more, no less. So the three things that matter in this business are the biggest things are the rent, obviously, food, and labor. So to a lot of arguments, because she does not a very good student of lean, because we've been married 35 years, is those three things have to go with sales as closely as possible. So even last year, she just shifted down gears and she lost 24 grand, I think, for the year, which is nothing, could have been a lot worse, or a lot of people are out of business and things are picking up good.
Good. I just meant seasonality wise.
Oh yeah, seasonality is basically make hay. Yep. But if she gets a 60-degree day or 55, she'll have a really good day, even now, as soon as it gets warm.
Good. So
let's look at this. I don't know, have you guys done this before, where you want to look at a graph that shows over time everything together, and I'll show you the advantage in a minute. So the formula there is equal to, we're going to start with the first data point, equals the sum. And we'll take that first week we were in business. And I'm going to put a dollar sign before and after the B. And that's just going to lock in that cell. So it's going to constantly take that cell and add it to the next one, take that cell, add it to the next two, the whole 9 yards. And then I'm going to go colon. And I'm going to take B2 again. And so I got the same number, but then when I drag it down, it's going to add the next one. And if I just double click on it, it'll do all the years, right? So now I'm going to do the same graph with that, highlight those two cells, insert line graph, and I'll do the same thing. And now on the bottom, if I explode this out, you'll see the the changes, variation week to week. But this top one is sometimes useful, maybe not for 5 years or 6 years worth of sales, but you can start to see the cumulative total here, of, I think it's like 1.8 million or something like that since she's open, something like that. So there's value, in looking at some types of data in this fashion, where you could have both of them. All right. So that's the cumulative sum, simple. And I'm afraid to touch these keys, but keep going. All right, we good? Everybody see it? the EWMA, which is the exponentially weighted moving average. It's basically the concept there is maybe I want to look at how a machine is wearing over time. So the data when it was new, I'm not going to give it as much weight as I am new data. So it's a weighted average over time. And I kind of put those rules in myself when I do that. But basically it weighs in the more recent data weighs more than the old data. And these statisticians love formulas. So same idea, right? There's a data point calculation. There's a formula for the center line, which is the mean. And then there's the control limits. And it's a plus and minus K, which means, the plus is obviously above the center line and the minus is below. EWMA. Probably never use it. But use the same Westinghouse rules on when do I pay attention. The control plans. So the idea is that I can't just, my process is going to go to entropy. Any process is going to fall apart if I don't touch it. That's how it works. I think I don't forget which law of thermodynamics it is, but if I leave it untouched, it's going to go off the tracks, right? So my control plan is, all right, how do I keep all these neat improvements that we made on track? It's a methodical rollout of changes. It's a way to communicate to everyone. It ensures compliance with changes through methods like auditing. So it sets up a schedule where we're going to go back and check, the idea of Hanse, follow up the last box in your A3 form. The transfer solutions, I think this is where, in Albrecht, you have so many classrooms, right? Because no one has time to pull everybody off the floor and show them PowerPoints. Like to have those classrooms, those routines, whether it be the closings, the A3 meetings, like so many of the huddles in the morning, the huddles in the afternoon. I mean, I know it, probably in the corporate offices, you guys huddle. It's those routines that allow us, to roll out. Some companies, the reason they put this in this course is that they struggle with that, with the communication, because they don't have the natural classrooms already ingrained in people's work week. It's ability to coordinate ongoing improvement, involvement, standardized data collection, make sure that gets right. Because again, the team is, the cross-functional team that does the black belt project, they're not the ones that are going to be day to day doing all this, so there has to be a plan, to sustain it and to train, data collection, everything. It's a way to measure process performance, stability and capability, and plan actions that mitigate a little bit of risk management, risk assessment and mitigation. So the control plan it's a clear, if you guys remember when we first started this, each of the 5 stages close, right? You basically have a closeout, you have a presentation to management. So this is the control plan, like the control C, where this would be the final closeout. It's a concise summary, the SOPs, supporting documentation, showing who does what, when and how. We're not going to open that can of worms in this hour, in terms of what's the best way, to communicate to people, the cookbook style, how to, and the communication planning, outlining messages to be delivered to who. So if you get the sense that we're talking about a big company here, largely that this is geared toward. The training plan as part of it, an audit checklist, the document that provides auditors with the audit questions they need to ask, and the response plan when the audit fails. I think audits are important. I think they can also be known as Gemba walks. If you establish Gemba walks, you can do 5S audits. You can do these kind of control plan audits as you go. That's the importance of setting up that classroom well, is you can do a lot of these things and that, where people are saying, oh, now we're going to have a safety audit. Oh, now we're going to have a project audit for the Six Sigma project Stephen did. the Gemba Walk covers a lot, 5S audit. It could all be part of that classroom nicely. The hard part's setting, getting it to be a routine and getting it, where there's humble inquiry involved, there's questions being asked. It's not a situation where you're just, going out and just, finding out where things are at. It's a management planning tool. Identify critical process steps, establish control mechanisms, identify and describe, monitor process performance, and meet customer specifications. And it's the most, as we know, guys, it's the most overlooked element of most big projects and small projects. You really have, that's always the thing, the Hansei, the follow-up is always the one that, because you're on to the next one, in terms of A3. So here's a control plan, just a template for one. Like a whole bunch of columns, on one Excel spreadsheet. In the first few are key processes and process steps identified, critical information regarding measurements documented and clarified. And the next couple are measure the target value, the upper and lower specification limits that we want to see, other key measurements like sample size, measurement frequency, who's going to do the measuring. This is all part of the control plan. And the last few are, where will this measurement or report be found? Good control plans provide linking information to other report references. Control plans identify the mitigating action or corrective actions required in the event of a problem. So that's an example of a control plan, formal one. And the SOPs, again, with this group, we'll open up a Pandora's box for sure, in terms of, because we're really deep in, thinking into this. The documents focused on process steps, activities, and specific tasks to complete an operation. I think I have the belief that there isn't anybody in America that reads standard operating procedures. I really don't believe it. Maybe I don't know, maybe medical or something like that, but they shouldn't be more than 2 or 4 pages. They need to be written to the user's level of detail. They need to be audited, easy to follow, not difficult to find. So this sounds a lot like ISO, right? A communication plan, it's common sense. Planning and preparing for the closing. So this is a big closing compared to what we do on Wednesdays at 1:15. Ensure the proper audiences receive, invites. Make sure everybody can get into your Zoom meeting. Make sure you know your audience. Key points and message. That's all common sense stuff that you guys do over and over and over and over and over. So the training plan, how are we going to manage the delivery of training? One of the primary reasons that the results will fall off if we don't train. We have a real robust way of training, TWI for one, TWU. The training plan must address these things. Who needs training, who'll do it, when it'll be conducted, what's the timeline to get everybody trained, what will trigger. This is like the detail that goes into a formal, if you were doing, a black belt project, in order to get your black belt, this is the kind of stuff you'd have to pull together for your project that you do. And then auditing, it's a systematic and independent examination to determine whether quality activities and related results comply. It's a way to get things to stick, right? I mean, it's the sustained part of the 5S is an audit. And it's really nice, like I said, if you could fit it into your regular classrooms that you have during the course of a week, which in the case of the mill, for example, is the Gemba walks. There's an audit checklist and how to do that. I'm going to give you the slide, so I don't want to waste your time reading it. But what's the response plan in case? And this is a really big one. What triggers us to take action? Who's doing it? Who's involved? When did it happen? How long you know, how long do we, what's our goal for how long it should take to get a response? And the constraints, and again, this is the risk management part of a project this size, you know, a Six Sigma project. We want to try to anticipate some possible constraints, you know, and try to mitigate them before they happen, right? That's risk management 101. But maybe lack of project sign off, lack of involvement in the design. Management doesn't have knowledge regarding the what's and hows to sustain. Financial benefits are not integrated into the business and tracked. Lack of buy-in from staff. All right, now the fun starts. Lean controls. These are some tools that you guys are very familiar with already. And it's interesting, you know, these are in the control phase of the DMAG. 5S for one. You know, we often think about 5S as housekeeping, right? Where in fact, it's really about, is the process in control or not? It's a visual way of knowing that our processes are in control. This is an old school, obviously, presentation, sort of cleaning and organizing. That's how most people think 5S, but it's really about visual work and are things in control? Is the process in control? The visual factory, that's the idea that anybody can walk into your office, into your plant, and know right away if everything's under control, right? It's colors and graphs and being able to sign boards, sell boards, and standard work is a control tool, provides consistency. And I'm not going to go through the 5S. You guys know those better than I do. Kaizen is considered a control tool. When I start to see things go off, you know, I would probably prescribe an A3, but you know, a lot of times that would trigger a Kaizen event. You know, get a team together, cross-functional team, and go through a Kaizen event. Kanban is a control. It controls material movement. It controls work movement. When do we make more? When do we buy more? Limits overproduction. You know, making things that we don't need right now. In the case of my wife's frozen yogurt, like she wasn't, you know, when cash is king during a pandemic, what matters is that her cash is in the bank so she could pay her employees, pay the landlord all night. We don't want it sitting in the freezer. Poke-OK is a control tool too, especially if we start to see data that, you know, that violates those Western electric rules. And it could be simply, the process is not mistake-proof enough. And the two types of Poke-OK are prevention and detection. Prevention is obviously the mistake-proofing tool that we definitely want to strive for, where it's impossible to make a mistake. My favorite example, as you know, is the gas cap is one. You know, where I can't drive off with my gas cap anymore on top of the roof like the old days, or I can't put diesel fuel in my gas car anymore and ruin my engine. That's impossible because of the diameter of the whole. So those are the types of mistake-proofing things that we want to strive for, preventing defects from occurring. We want to remove the possibility of errors and make occurrence of errors impossible. One of my favorite ones is Atlas. I know Andrew's not on this today, but largely we watched the operator putting not the operator, the guy I saw, there's a black dot on 5,000 little parts that got to go to Pratt & Whitney. And his job was sit on a stool on his bench with alcohol and a rag and remove the dot, and he wanted to put that on the A3 board because he said that the process sucked. I don't know why he said that. I mean, 5,000 parts with a rag and some alcohol seems like fun, right? But the cool thing was the final result, and Pratt & Whitney uses this one as an example of mistake proofing, was the reason the dot, if you go 5Y, it was because it was real easy to take the part and put it in the press upside down. And if you did that, you end up with a defect. So years ago, they said, I got an idea. We got a mistake proofing idea. We're going to put a black dot on the top So the operator sees the dot and they make sure it goes the right side up. All right. So someone had to put the dots on, someone had to wash the dots off because the customer doesn't want their parts with black dots, like Sharpie dots on the top of the part. The mistake proofing tool was they redesigned the tool, the A3 team, with the help of the tooling engineer. So it was impossible to put the part in to the press the wrong way. If you put it in, it just wouldn't sit well. So just think about the number of hours over the course of a year. That's an example of mistake proofing prevention.
Hey, Bill.
Yeah.
I'm sorry, all of a sudden I have maybe a silly question, but I find myself thinking that 5S and the Pokayoke and this kind of Kaizen, why is it in the control section? Should it be on the, for example, in the improve section? Why are we, or can they be in both? I lost it a little bit.
Yeah, I think that's a really valid question. I think it could be in both, because I think we talked about it in the improve phase too. We got some lean stuff. Yeah. And if you think particularly a couple things. One, the 5S is definitely a control tool, in maintaining. And then even as I start to do my control charts, I see things out of whack, things like mistake proofing. I think they fall nicely in the control piece. So yeah, I think the answer is, it can fall in either phase. And then the three methods of Pokayoke is contact. And that example of the contact method is, I can't put diesel fuel in my gas car. That's an example, because the size, it just doesn't fit, right? Constant number method, a fixed number to ensure a certain number of motions are completed. I see people that, if they reach and grab a part, there's a laser and a certain number you can grab. And then a sequence method is a checklist. A checklist is a mistake proofing tool. I've been using one for 30 years. This is my week. This is so I don't screw things up like I did at 1:15 today. I'm on the meetings I'm supposed to be on. A checklist is a method of mistake proofing, much better than the work instruction. Because the work instruction, a lot of times, if you put it in a checklist form, if it's possible, much simpler. TPM, focus on reducing and eliminate equipment malfunctions and where and knowing when to replace things before they fail. It's a proactive approach. Daniel's on here. Roy's not today, but Ulbrich does a really neat preventive maintenance process in the mill. And it was on Les's machine, the first one I ever saw. I forget which one that is, Stephen. 4?
3Z.
3Z. And largely, for years, basically before this once a day, an operator would go around the machine. There's a set route. And it's basically like checking your car before you drive it. And it takes less than a minute to do. It's something that John Peterson designed, the process. But largely, you don't want to wait until it fails. And it's interesting because I remember saying to Arnie years ago, "Hey, Arnie, what's the one piece of equipment that never fails?" And his first, without hesitation, he said the 3Z. And that was the only one at the time that TPM was done on, right? But basically what it involves is, in a lean company, who's responsible for quality? Everyone, not the quality department. In a lean company, who's responsible for improvements? Everyone. In a lean company, who's responsible for the machines not going down? Everyone, not just the maintenance department, right? Because unfortunately, when the maintenance department comes, it's usually expensive, so it's these daily checks. There's been, it's real easy for the operator on that piece of equipment to check the oil levels, the liquid levels, because everything has a sight glass now. And then when they see it starting to drop, there's a red flag that goes up. And when maintenance walks around, they see the red flag and they know to go over and top things off. But the operator is capable of topping off or making, doing some of those same things. And Jidoka, again, when you think about Jidoka, think respect for people. The way Stephen and I think about it, we've had hours and hours of conversations about it, is that people do people work, machines do machine work. The idea of Jidoka is stopping production immediately once a process failure occurs. And I think I told you the story about Toyota. They were in the loom business, Toyota Loom Works, and they had the best loom business in the world, because simply the fabric, as soon as it started to get caught, the loom would stop. Okay. But the concept of Jidoka is about respect for people, in that the grandfather Toyota thought it was very disrespectful for people to spend hours of their life they couldn't get back untangling this fabric out of the loom. So they made one where as soon as that fabric started to get caught, the loom stopped dead, automatic. So some people call Jidoka automation, which is interpreted as giving machines human touch, a human mind, where they're thinking along. Jidoka, respect for people. Hey, you guys done? You're done. Just,
So LMC does that on the blasters. They have the maintenance department
what's that? Tell me again.
checklist.
What's that, Daniel?
LMC does that with the blasters, preventative maintenance.
Yep. It's
Should be on the
interesting.
hard coat line too.
What's that?
Should be on the hard coat line too. I did that with Jordan.
George still there?
There's the numbers around the line, and they each go to a checkpoint for the operator to go every shift. And I don't know if they're still.
They're still doing it or not? Yeah. I think, the thinking is an A3 that PTA, one of their first A3s was the maintenance guy, because I always ask, if you own the company, what's the one change you'd make in your job right now? And he wrote, I don't want to keep going back to the same problems over and over, right? So basically what would happen is he would go in and, you get a call to go see a certain machine. The operator would go to break or whatever, and he'd fix the machine and then leave. So the idea there is with TPM is that we want think of the maintenance guy as a surgeon who's not going to come and just put a Band-Aid on you, right? We want to use the surgeon when you're bleeding profusely, or you're doubled over in pain with appendicitis or something. We don't want them in there putting Band-Aids on paper cuts. Plus, it just gives the operators ownership in their own equipment. That's a part of it. And it's interesting. It doesn't only apply to the production floor, TPM, because there's vital pieces of equipment, especially in quality labs and things, where people have started doing TPM. So I think we're done. If any other questions, sorry, that last half an hour, with all those control charts but they're not on the test. So, all right, guys. I'm gonna get out of here before I screw up again. See you guys. Have a great night.
Thank you.
Thank you.
Thank you, Bill.
Thanks,
I'll
Bill.
finish the recording.
So, Bill,
Thank you.
So,
Bill,
Joe.
next week is a review of the entire process? Or...
Yeah. Yep.
Okay.
Yeah, basically, I'm going to highlight everything that I think is going to be on the test. Yeah.
All right. See you next week. Thank you.
See you next week.